Hello, students. Welcome once again. Last time we saw in our lesson 2 that when a body is floating in a liquid, then these key equations are true. The weight of the floating body is equal to the weight of the displaced liquid and is equal to upthrust equals apparent loss in weight equals true weight minus apparent weight equals the density of the liquid times the volume of the displaced liquid times g, acceleration due to gravity, and this. And we also saw that n is equal to this. So we can calculate VD as A times LS, where LS is the length of the submerged part of the floating body in the liquid. We also saw that the mass of the displaced liquid and the mass of the floating body are equal. Then VD is given by Vs. So when the body is floating, then the volume of the liquid displaced is equal to the volume of the submerged part of the body. And it is also equal to A times LS. We also saw this equation. Now I want us to take example, a typical question on this and solve. So let's look at question 1. A cylindrical tube of diameter 3.3 centimeters and mass 4,000 grams floats in an acid whose density is 6.5 kilogram per cubic meter. We are asked to calculate the depth to which it sank in the acid. And we are giving G acceleration due to gravity to be 10 meter per second squared. How do we solve this question? So I want you to pause the video and write the question down so that when I start writing, I start solving, you can follow it. All right, thank you. All right, so let me look at the solution. So we are doing question 1. And what information are we giving? We are giving diameter of the tube as 3.3 centimeters. And this one in meters gives us, we divide it by 100, we get 0.033 meters. I don't want to go back and waste time because the density has been given in 8 SI units, so the others must also be there. So we are given the mass of the tube to be 4,000 grams. I divide it by 1,000 and I'll get 4 kilograms. We are also given the density. Let's use rule for density. Density of the acid has also been given to be 6.5 kilogram per cubic meter. So what do we want? And we have been given G to be this 10 meter per second squared. They want us to find length, the depth to which it sank, right? So in other words, we are looking for, assuming, let me do some slides drawing here. Assuming this is a container. Okay, should I even? I want to separate it. Let me include it in the diagram. Assuming we have this. Okay. This is the acid. This is the tube flowing. Okay, this is a tube. It's just a cylindrical tube. So we are looking for this. This part is what we are looking for. The depth to which it sinks. So let me call it LD. And that depth is the same as the LS. The depth to which it sinks. He's trying to ask us to find the LS. So what do we do here? What do we do? So we know that from the law of flotation, we we know that the weight of the tube must be equal to the weight of the displaced acid. So here the fluid becomes the acid. All right. All right. So let me move on to the next page. So how do I get the weight of the, let me divide my board. Okay. So I'm question 2, question 1. I'm continuing from here. So weight of the tube. How do I find the weight of the tube? Weight of the tube is equal to mass of the tube times G, okay? And what is the mass of the tube? Is 4 kilograms. You can go back and check, times 10. This gives us 40 newtons. And according to the law of flotation we have stated here, so it means that the weight of the displaced acid is also what? 4. How do we call it? Yeah, 40. So we can say that weight of the displaced acid is what? 40 newtons. And that also implies that the upthrust is also 40 newtons. All right. That is according to Archimedes' principle. According to Archimedes. All right. So what can we see? We also know that, we know that upthrust, how do we find upthrust? Is the density of the acid times volume of the displaced acid, right? Times, so excuse me to say, let me use VD for volume of displaced acid times G. So what is my focus? My focus is to find the length of the submerged parts. This is what I'm looking for. We are looking for LS. We are looking for the depth to which it will sink. And that is the L. Depth is length. LS. You see, I want to show you something. Here, our focus, we want to get VD. When we get VD, we know that VD is A times LS. And we can get it from there. So that is where we are gearing towards. Okay. So here we know the upthrust to be 40. And the density of the acid has been given to be 6.5. So times VD times J. Sorry. Our J is 10. So what do we do? What do we get VD to be? It's going to be 40 over 6.5 times 10. So we will eventually get our VD to be 40 over 65. And according to our calculator, we are going to get 6.15 meter cube to 3 decimal places. And also we know that VD is A times LS, where A is the cross section of the tube. A is the cross section. So you can see that per the information we were given the density of the diameter of the tube, right? So because we were given the diameter, you can divide it by 2 and get your radius, but I don't want to use that. I can calculate A. How do I calculate A? I can calculate A A as pi d squared over 4. All right. So pi is a constant. So you can even enter the pi directly on your calculator. So the diameter was 0.33 squared over 4. That's all. And this is going to give us, to 3 decimal place, we are going to get 8.553 times 10 exponent negative 4 square meter, or meter squared. Okay, so this is what we are getting. Now let me call this equation star for reference purposes. I'm not doing simultaneous equation here, but just for reference purposes. Okay, so what do we do? So I'm still on question 1. So I'll say from equation star, check equation star. We know VD now, we know E, we are left with LS. What is VD? What did we get for VD? We had it to be 0.615 is equal to A times, and our A has been found to be 8.553 times 10 exponent negative 4 times LS. So this is our final step we are doing. We divide through by LS. We are going to get 0.615 out of 8.553 negative 4 is equal to LS. And we will eventually get LS from our calculator. We are going to get 719.046, and our answer will be meters. So how do I conclude? Go back to the question and conclude accordingly. Calculate the depth to which it was sink. Hence, the tube was sink 719.0 to 2 decimal. You can see that, right? Good. So that ends the first one. I hope it's clear. Right, so you can go through and play again and follow it. Now let's look at the question, the second question. Question 2. We are given a rectangular wooden block weighs 100.0 grams, flows in a liquid of density 0.8 gram per centimeter cube. If 5.0 cm of its length is submerged in the liquid, what is I, the volume of the liquid displaced, and I, the cross section of the wooden block? Interesting. This is also interesting. Very nice question. How do we solve this? So let me create a new page. So this is my question 2. This is question 2. Solution is what I'm going to do. So we have been given the mass of the block, the wooden block, to be 100 grams. And this is equivalent to, when I divide it by 1,000, I'll get it in kilogram. 0.1 kilogram. We were given the density of the liquid. Let me use rho for that, as 0.8 grams per centimeter cube. Let me move it to its SI unit. I multiply by 1,000, because we know that 1 gram per centimeter cube is equal to 1,000 kilogram per cubic meter. So when you use this conversion, you are going to get that. So you multiply by 1,000, get 8, sorry, let me clean this and clean this. So we are going to get 800 kilogram per cubic meters, right? Then we are given that we said that 5 cm cube is submerged, right? So let me call it LS. LS, that is the length of the submerged. Length of the submerged part is our LS, and it has been given to be what? 5 centimeters. You can go back to the question, please, and pause and check. So we divide by 100 and we get 0.05 meters. Now, what is the question asking us to do? The first part of the question is asking us to find the volume of the displaced liquid. So what do I say? My target is to get upthrust. So we know that from the law of flotation, we know that the weight of the block should be equal to the weight of the displaced liquid, right? So if I find the weight of the block, that will be the same as the weight of the displaced liquid. And how do I find it? And this is the same as mass of the block times G. And this is what? 0.1 times 10. And this is 1 newtons, right? 1 newton. So we can say that the upthrust is equal to weight of what? The displaced liquid. And this is what? 1 newton. I hope we are flowing. But we also know that upthrust can be calculated as the density of the liquid. Here is not as it is liquid, times volume of the displaced liquid times acceleration due to gravity. We have derived this equation in our previous lessons. Did we derive? We talked about it. Let me put it that way. So this is 1 is equal to, we are answering the first part of the question. 800 times VD times G. I've been leaving this G. So times 10. And what do we get? 1 out of 800 times 10 is equal to VD. We divide through by that and we get it, okay? So this is going to give us VD equals 1 over 8,000. And 1 over 8,000 will give us 1.25 negative 4 cubic meters. Great. So how do I conclude? So question 2I is what we are doing. I'll say volume of the displaced liquid is 1.25 times 10 exponent negative 4 cubic meters. Right. So now the second part of the question is asking us to, let's go cross section of the wooden block. We are looking for A. That is the A. The cross section is the A. So I, if you know, we know that, but VD A times LS. So this is very simple. It gives us the LS. We have found the VD to be 1.25 times 10 exponent negative 4. VD is volume of the displaced liquid, okay? Then A. So to make things more presentable, I will say that where A is the cross section. So we can now go back and continue and see 1.25. I'm still going to work this times 10 exponent negative 4 is equal to then A times this one, okay? And my LS was given as 5, and we saw and we converted and we got this. Haven't you? Are you not done? You are done. Times 10 exponent negative 4 over 0.05 equals A. And this gives us 2.5 times 10 exponent negative 3 squared meter. So I will say that the cross section of the block, or of the wooden block, the cross section of the block is 2.5 times 10 exponent negative 3 meter squared. Great. So this answers our nice 2 questions that were given to us. Please, you can go back and play the video slowly and follow it. If you have any question in the comment section, kindly send it to me. All right, I want you to try this on your own. Pause the video, write a question down and try it. And when you try it, this is the answer you get. This is what I got for the first one when I tried it, and this is what I got. Then try this one also. So I'm giving you 2 questions. Okay. This is the second one. When you try it, you are going to get this. All right. On this note, I want us to end here and hope to see you again